Good afternoon, this is Andy Schweitzer, and this is a little pre-lab for the copper iodide lab. The name of this lab is the determination of an empirical formula. A couple of things we'll talk about in this video is, okay, what is an empirical formula? Why will it apply to this particular lab? Some background information. And maybe a tad about the actual procedure. Okay. So what is an empirical formula, and why does it even really matter for this particular lab? Well, the definition of an empirical formula is the simplest ratio of atoms. Now, in a molecule, for example, we could have C6H12O6. This is an actual ring-shaped molecule of glucose. But in this case, this is the actual number of particles in an actual molecule. If we have an ionic compound, then these things don't form molecules. They form what I refer to as bulk crystals. These things are big piles of cations and big piles of anions, of which case they are held together by electrostatic attraction. And this particular crystal might look like this. Okay. So because there's no actual molecule, there's just a pile of cations and anions, all we do is simply state, okay, what is the ratio between these things? So in this lab, we're going to produce a chemical called copper iodide. Now this is either going to be CuI2 or CuI. Either way, it is an ionic compound. It is cation, which is, let's go with plus, in this case, plus 2 and minus 1, plus 1 and minus 1. So these are our two options we're kind of looking at here. So this is going to form a bulk crystal ionic compound, and we're trying to figure out from experimental data which type of formula this actually is. All right, so a little bit about the actual chemical reaction. This is forming an ionic compound from a metal and a non-metal. So the metal is going to oxidize to give electrons to the non-metal. This is called oxidation. The non-metal will receive electrons, this is called reduction. So the copper metal, any kind of oxidation-reduction reaction can be usually described in what's called half reactions, showing 1/2 oxidation, 1/2 reduction. And I'm going to show two options here. One's going to be one version of an answer, and one is be the other version of an answer. And I think you'll kind of see what I mean in a moment. But copper metal will oxidize to form copper plus 1 electron, and then the iodine. Now iodine happens to come in pairs, so there's two iodines there, but each individual iodine may look like this, has 7 valence electrons, and really each individual can only pick up 1 electron, but since they come in pairs, then we will deal with them together. So these guys are going to be picking up electrons, in this case 2 electrons, 1 each, to form 2 I negatives. In the end, the copper and the iodine will attract towards one another via electrostatic attraction, and we'll get a compound that's called copper iodide. This is plus 1, this is minus 1. The other option is for the copper metal to oxidize to a copper plus 2 version, which is going to be giving away 2 electrons. Therefore, the iodine, okay, I2, will again still pick up 2 electrons, 1 each, so they're not changing, to form the same 2I negative. But in this case, the first one, this guy has to happen twice to fill 2 electrons to fill the actual spots. whereas this guy only requires 1, and it dumps off 2 electrons, easily filled. Either way, this guy is going to form copper iodide like this, plus 2 charge and a -1. So in this case, in our laboratory, we're going to basically look and see from investigation what's our ratio of copper and iodine in the end. We're going to do this through a couple simple weighings. All right, so a little bit about the actual lab, a little bit about this procedure. This will by no means replace looking over the procedure, but we have a thin strip of copper, and it is going to be kind of cupped like so. And there essentially are 3 different weighings. We have the first weighing, which is just plain copper, nothing done yet. We're going to then take the metal, and we are going to take some iodine on there. I would pull it pretty good, and we'll use tongs to grab onto this thing. Not very good tongs. Okay, but grab on this thing because we don't want to heat or hurt our fingers, I guess. A little flame. And as the heat arises, it quickly vaporizes the iodine, sublimates it. It may go to a liquid for a very short period of time, but you can take a look. But you get all this purple smoke going on, which is why we do this in the fume. This is just iodine vapor. It looks cool, but there's no real chemical reaction occurring here. We're just going from a solid essentially to a gas very quickly. But on the surface here, once all this is gone, let me erase this here a little bit. Okay, once all this is gone, you'll see a pasty white little coating on here. And that is, in fact, an ionic compound of some sort of copper and iodine compound. I don't know this guy. It's either going to be copper iodide, or it's going to be copper 2 iodide, copper 1 or copper 2 iodide. So again, at this point, we'll weigh it again. Okay, now this is going to be only thing we really added here, hopefully, and we don't want to overheat this thing. Overheating this thing might allow the oxygen from the atmosphere to react with copper to form copper oxide, which is darker brown and black. This stuff here is sort of a pasty white, okay, and flicks off with your fingers relatively easily. Either way, at this point, our second weighing is copper plus any iodine that happened to react with this copper. Then what we do with this thing is we simply scrape it clean and clean it all off, clean it up nice and clean. Remove essentially any copper and the iodine. So at this point, our last weighing is only going to be of copper, but it's going to be copper minus, well, anything that reacted. So we could compare a few things and say, well, between the first 2 weighings is the difference between any iodine that reacted, and from the beginning and the end would be the difference between them. Hopefully it weighs less. Would be 1 in the sense that how much actual copper reacted, because we removed iodine, but the iodine wasn't in the first one to begin with. Now here, this is going to tell us, again, how much copper reacted. So think about that, and that's our reverse lab. Our overall goal is to figure out the empirical formula. Empirical formula is the simplest ratio of atoms. We have done this in a number of ways, but in some sense, you should be aware of the fact that we're starting with a mass, and we want to get to moles. And once we have moles, we want to simply get our simplest ratio, which will divide by the smallest one, and that will give us, for every 1 copper, we should get either 1 iodine, or for every 1 copper, we should get 2 iodines. That's our only options. And that may be a little more information than I need to give you, but take a look at it. It's a neat little lab. Thank you.